Good morning, students. Welcome to PPS class. Today we will discuss another important concept from your second unit, that is unions. After the discussion of structures, this particular topic unions we have as part of structures only. We discussed about structures into details. What is a structure? How we define a structure? How we initialize a structure? And what is array of structures? All those things we have discussed. But complex structures forms also we have discussed. But we left with this unions concept. Okay, we haven't discussed anything related to these unions in your second unit. So in today's online session, I will try to cover these unions because they are closely related to the structures concept. Okay, you don't see a major difference between a structure and a union. The way how we declare, define, and initialize a structure, initialize a union, it is same like your structures only. Okay, the way how we create structures, in that same way we create unions. Okay, then why we have this separate concept unions, in the sense in terms of memory sharing. Okay, uh, there only both these concepts, your structures and unions, will differ with each other. Okay, you will see the difference in that particular thing only, where they allocate memory to their members, okay, to their fields. Okay, so in today's session, hopefully we will see the definition of this union and the related concepts of this union. It's a small topic, so I don't think it will take much time. Okay, so let's just enter into this topic, unions. Okay, if you see the definition of a union, we are saying it is similar to structures. See, there is a big difference between similar and same, these two words. We are not saying union is same as structure. We are saying similar. Similar in the sense some properties will be common, but union will also have its own different properties. Okay. So a union is similar to a structure. Okay. As it is also a collection of elements of different data types. We define structure like a structure is nothing but it is a collection of heterogeneous data items, or we defined a structure as a collection of elements of different data types. Here in this particular definition, your union will have the similar rule. It is also a collection of elements of different data types. Okay, a union is a construct that allows memory to be shared by different types of data. When we are creating a union, in that union, we are going to have items of different data types, where every item will have its own memory consumption, isn't it? But when we create a union, all my data items into the union, whatever members I kept, whatever fields I kept, all they going to share the same memory allocated. Okay, they are going to share the memory. Okay, sharing of memory possible through unions only. Okay, the concept of sharing of memory is possible through unions only. Okay, I will explain into detail, don't just bother about it. So here in the next point, you can see in simple terms, the integer memory locations can be shared to can be used to share the characters. Okay, uh, because we know that an integer, if it is a 16-bit system, how many bytes of memory it will consume? Only 2 bytes it will consume. Okay, only 2 bytes it will consume, your integer. And we know that to store a character, how many bytes we need? Only 1 byte we need. Only 1 byte we need to store a character. Irrespective of the system, the character will consume only 1 byte. But integer, if it is a 16-bit system, it consumes only 2 bytes. So this 2 bytes, if I have a union declaration in it, assume that how we are going to declare that and all we will discuss soon. So inside a union, suppose if I have an integer variable int a, and this is a character c1 comma c2, two variables of type character I have, one variable of type integer I have. So now what will happen in the sense, when allocating memory, to this particular union, when allocating memory, what the compiler will do, if it is a structure, how the allocation will be, and if it is a union, how the allocation will be. If it is a structure, the allocation will be the sum of all types, isn't it? For integer, assume it is 16-bit compiler only. Assume it is 16-bit compiler only. So for integer, how many bytes it will allocate? Only 2 bytes it will allocate. And for character, for this C1, 1 byte, for this C1, another byte. So overall, how many bytes? If it is a structure, overall 4 bytes it will allocate if it is a structure. But if it is a union, we said sharing of memory is possible in union. So if it is a union, how many bytes it will allocate? So union, how we declare? Struct, I'm creating my temp, okay? Temp structure I'm creating. So if it is a union, I use the keyword union only. Union and same temp name I'm giving. So init, same thing, I'm creating one integer variable. So int a, and the character C1, C2. So now the thing is quite different. Okay, C1, C2. See here, now what will happen in the sense, when you create the member, when you create the variable of this union type, that variable will consume only 2 bytes. That is what's the concept over here. It will consume only 2 bytes. Why it will consume only sorry, why it will consume only 2 bytes in the sense, because see, when allocating memory, union will look for the maximum amount of memory required to store a particular data type in that. Not the sum of memories, but the maximum amount of memory required to store a particular data member. So in this case, which one is in between character and integer, which one is having the highest memory consumption? Your integer is having the highest memory consumption. So we said it is a 16-bit compiler. So how much memory it will consume? It will consume uh, 2 bytes to store this A. To store this A, how many bytes? 2 bytes it will consume. And to store the character, how many bytes? Only 1 byte. So what it will do, it will allocate only 2 byte, which is sufficient to store the maximum data item, which is sufficient to store the maximum data item. And it is not going to bother about this C1, C2. It will make this C1, C2 to share the same 2 bytes. To share the same 2 bytes. That's how you remember, ma. That is more than enough. Okay, that's how you remember, because sharing of memory concept is there. So it is not going to allocate any memory for the smaller data type items. It will allocate the memory only for the larger data type item, that is integer. So it has allocated only 2 bytes. And when storing the C1, C2, it is going to use the same 2 bytes which it has allocated for the integer for these characters as well. So now overall, how many bytes it will allocate for creating this union? Only 2 bytes. That is the reason why your union is memory efficient when compared with what we call structure. It will consume only 2 bytes of memory, your union. But whereas your structure, it is consumed 4 byte, because it will allocate the memory for every data member of its own. Okay. So, but union, it will follow the sharing of memory thing. Hopefully it is clear. Okay. So the union follows the same format and syntax as structure. The way how we create a structure, in that same way we create the union as well. There is no difference between the creation of, declaration, definition, and initialization of a union as with the structure. Okay, it is same as your structure. That's the reason we are not going to discuss those things. Okay, type defined structure, tagged structure, the way how we create it, the same principle you can apply to the union as well. Okay, the only difference between declaring a structure and a union is the keyword. For declaring a structure, we use the keyword struct, but for declaring a union, we use the keyword union. Rest of the things same. There is no difference between that. Okay, rest of the things same. Okay, only the keyword In case of structure, we use struct keyword, and in case of a union, we use union keyword. Okay, only that difference we have. Here you can see integer num. When I'm creating a union, I have created integer num and a character array of 2 okay, 2 elements, character array of 2 elements, and integer type of num I have created here. This is character array and this is integer num. So this integer num, assume it 16-bit compiler. So it will consume only 2 bytes of memory, and here this character, it will consume, again it is an array of 2 bytes. So 2 bytes it will consume. So maximum required is 2 only. So it will allocate only 2 bytes. As you can see here, I have given. So this entire memory at one time is used to store the num, and at another time it is used to store two different character variables. Okay, character array of 0 and character array of 1. Likewise, these two, the individual items from your character and this num item is going to share, are going to share the same memory. Hopefully this concept is clear. So referencing to a union, it is same like your structure. The way how we use dot operator, and in case of normal structure member, normal structure variable, and arrow operator in case of a structure pointer to structure. Same way we can use the dot operator to reference the individual items of your union, in case if the union variable is a normal union variable. And if it is a pointer, if your union variable is a pointer, you can use the arrow operator to access the members. Okay, here that's what they said. If it is a normal variable, use the dot operator, and if it is a pointer to union, use the arrow operator. Okay, initializing, it is same. You can follow the individual initialization, you can follow the set of values initialization, anything you can. Okay, so here that only they have. When initializing a union, the values must be enclosed in a set of braces, even if there are only one value. Okay, even if there is only one value, you can use the set of braces. Same like the way how we declare the union, declare the structure, in that same way you can declare the union. The way how you initialize a structure, in that same way you can initialize the union. Okay, but all the members at a time you cannot initialize, because we said now they are going to share the memory. So assume that you have two things, same union you are declaring, union temp, and in that say you have two variables, integer num, and say character, and chray array of 2, like this you have. So at a time any one thing you can initialize, not all. At a time only any one of the data member you can initialize. Either integer you can initialize or characters you can initialize. If you initialize both, what will happen? Somehow it is going to override the data. Say suppose at one point, and assume that the member of this temp union is T1. This is the member I have created. So now this T1 will become the variable. In this way also we can create the variable. So now what I am doing, T1 dot num equals to some 40. Okay, take some big value. Okay, 16,400 something like this, you have taken the value because it has to affect all the bytes available. Okay, so 16,400 I have used, and then what I am doing, T1 dot chray of 0 the first byte I am affecting 0 equals to say some capital A you have initialized. Then T1 dot chr, second byte I am affecting chary of 1. This is 0 of 0, and this is 1 of 1 equals to say some z I am initializing. So now what will happen? Indirectly I have changed. I mean, how many bytes it will allocate? It will allocate only 2 bytes. If it is a 16-byte compiler, 16-bit compiler, it will allocate only 2 bytes. So that 2 bytes, assume it has allocated like this. Okay, so in that 2 bytes, what I have done, initially I have stored 16,400. 16,400 I have stored into this, into these 2 bytes. Then in my next statement, I am modifying CHR ARY of 0. That is nothing but I am trying to modify this first byte. Here I kept A. And in the second byte, what I kept? I kept Z. So at a time, if you have done the initialization of all the data items, what will happen? The recent initialization will override the older initializations. So num value, now it got overridden with these two initializations. So if I printf say percentile d comma uh, t1 dot num, will I get that 16,400 in the sense? No, because it got overridden. Same memory, these two variables, same memory they have used. So whatever value I have stored using num, it is overridden now by this a and z. So you will see a different value over here. You will not see the 400 thing. Okay, you will see a different value. So just now I will demonstrate that same thing with the help of a program. Okay, when using struct, how the thing will be, and when you use the what we call a union, how the thing will be, I will demonstrate now. So quickly go to the program. So here only, okay, I'll take a new file and I'll delete this. Okay, now I will save this. Okay, union demonstration we are doing. So union demo dot c. So first what I'll do, I'll create a structure and I will show you how this thing will be. stdio.h. Then yeah, I will create one structure first. Type def struct. Okay, in it I'm keeping integer a and character ch of ch array ARY of 2. Okay, so generally we are dealing with a 32-bit compiler, so it will consume 4 bytes integer. So I can store 4 different characters into that. So I'm creating 4 now. Okay, and this I'm calling as S1. Okay, I'm creating only one variable S1. So now int main of void. So here what I'll do, initially I'm initializing s1 dot a. Okay, equals to, give some big value, 64,332, some big value, so that it affects all the what we call all the bytes, all the 4 bytes. Okay, now I'm using s1 dot ch array of 0, 4 bytes, all the 4 bytes I will try to modify, equals to, I'm storing a. Okay, same thing storing b, same thing storing c. That is what we want. Storing b, then storing c and d also, 4 bytes now. So c and d also. So when I print the values, printf, first I'll print the integer. Okay, first I'll print the integer. So give some message, structure members, backslash n. Okay, now print the members, printf. First you print the integer percentile d comma s1 dot a. Integer got printed. So now for printing array, I'll make use of a loop. Okay, so just create a normal integer uh, counter. Now printf printf characters. Okay, characters, four different characters we have. Okay, four different characters we have. So that only I will print through a loop. For I equals to 0, I must be less than what is it? How many? 4 na? 4 I plus plus. Okay, then printf percentile C characters we are printing. So percentile C, then S1 dot chary of I. Okay, so while initializing here, I have done mistake. This is 1, this is 2, this is 3. Okay, likewise it will go. Okay, then come out and return 0. So when you save this and compile, s1 dot a, sample s1. Okay, then run. As you can see, whatever values here, just give some space. Control C. Printing only, no, not reading. Printing only. Just give some space. Compile and run. As you can see, it is giving the value of integer 64,332, which I have initialized, and all the characters chary of 0, A, B, C, D, all characters it is printing. So no, because your structure will allocate memory differently. For integer separate 4 bytes, and for character separate 4 bytes. So overall 8 bytes it will allocate over here in this case. But if I go with a union here in place of structure, if I go with a union, okay, same sample only I am creating, sample s1 only I am creating, all the things similar to that only I am creating, and here in place of just to have the difference, I'm making it as union now. So now if you make it as a union, then see the things how it will be. Spelling mistake. Union. Okay, it got compiled successfully, and when you execute, you can see first integer we have initialized with 64332, then character we have initialized with ABCD. Because your character and integer going to use the same memory, 4 bytes of memory. So whatever 4 bytes it has allocated for A, that memory we have initially we have initialized with 64,332. Later we changed those same memory location with ABCD. Okay, so that's the reason when I'm printing the integer value, I'm not getting the accurate value because it got overridden with ABCD. And but when we are printing the characters, we are getting the ABCD only. So now what I'll do is I will reverse the concept. I will just remove this from here. First, I will initialize ABCD, then I will initialize the integer. Okay, now you see what will happen. Compile it, successfully compiled, execute it. You can see integer value perfectly we are getting 64,332 because later we have initialized. But ABCD initially we have initialized Later, this ABCD got overridden with 64,332. So we are getting characters, some different characters. We're not getting the proper characters over there. As you can see, some L, some under root symbol we are getting. So this is how the union members, the only difference between structure and union is union members will share the same allocated memory for storing all their members. Differences, if you see difference between union and structure, it is an important question. Sometimes they will ask for 2 marks, 3 marks, 5 marks kind of thing. Okay, so here the topic of comparison I took on the what we call left hand side as the column, and then in the description about that topic, okay, I took. So quickly, the first one, the basic definition, how it is different between union and structure. Here you can see separate memory locations is allocated to each member of the structure. Each member, each field of your structure is going to have separate memory in the structures concept. But when we see the same in what we call union, all members of the union share the same memory. The difference already I have shown. Okay, the declaration thing, nowhere it is different. Structure declaration, struct name followed by the variables like this. You can union name followed by the variables inside fields like this. You can. Okay, there is no difference between a declaration of a structure and a declaration of a union. Okay, only difference in the declaration is the keyword. Struct for declaring a structure we use, union for declaring a union we use. How they will consume the memory size, in the sense size of a structure is the sum of all the individual data members. Okay, size of all the individual data members we need to sum up, and then we will get the final size of a structure. But when in case of a union, how the size will be, in the sense size of the largest member. In our case, it was integer, and we know that integer will consume 4 bytes, so it will allocate 4 bytes. Size of the largest member. Okay, it is equals to the size of the largest member in case of a union. Storing value, it will store distinct values for all its members. Okay, whatever number of members you will have inside a structure, for all members it will store the distinct values, different values. But as we know, for a union, all members will hold the same value. Okay, all members will hold the same value. Okay, at a time. A structure can store multiple values of their members, different members in it. But a union, it will hold a same single value for all its members. Okay, that is what the difference. And way of viewing, provide single way to view each member location, each memory location, and it will provide multiple ways of viewing same memory locations. Okay. Uh, you can create an anonymous union, but you cannot create an anonymous structure. Anonymous means without a name. It is an advanced level concept in data structures. Maybe you need this. You will study this. So a structure without a name, it is not possible. But a union without a name, it is possible. Okay. So hopefully you understood this unions concept. I have shown the definition, I have shown the declaration definition, how to do, and the differences also we discussed between structure and union, and the program demonstration. Okay, how it will share, how a union's members will share the same allocated memory for their creation and for their usage. Everything I have explained. Hope it is clear. Thank you, students.